So working on our midterm study guide for college algebra, I'm going to work number 23 with you. This is the beginning of the U substitution concept. So we've got a quadratic in form equation. It's not truly a quadratic. This is not just to the second power like a second degree quadratic, but it is in a form that if you think about this middle stuff, if we let that be just an x or just a y, just a variable, and we're going to use u as the letter the book uses, u, then this is the square of that. So it's set up where you've got something to the first, and then this would be it as squared. So we let this middle stuff, we let x plus 5 to the 1/3 equal u. We pretend that's just a u. If that's u, this is u squared. If I were to square this term, you would multiply your exponents, and 1/3 squared would multiply to be 2/3. So this is the square of that. So if this is u squared. It doesn't have a coefficient, so I'll just have u squared plus 4, I'm calling that u, plus 3 equals 0. So we make this substituted quadratic equation so we can then factor it or use the formula on it to get our u solutions. So we get two solutions for this substituted quadratic of -3 and -1. Remembering that these aren't our final solutions, these are the substituted ones. So once you get to this point, you have to unsub. You go back to your note that you made, what you let u stand for, and then you change it back in. So u is really this x plus 5 to the 1/3 equals -3. And this u is x plus 5 to the 1/3 that equals this -1. So you're basically saving the hard part to do till later, like this 1/3 power. How do we get rid of that? We take 1/3 to the 3rd, and then you multiply exponents, it would undo that. It would just be 1. So you raise that to the 3rd, so you have to raise this side to the 3rd. That brings that down as x plus 5. All that's canceled, so just x plus 5 to the 1st. -3 to the 3rd is -27. And then I can solve that by minusing 5, so I save that as well, for a final answer of -32 on that. Same series of steps here. Because it's to the 1/3 power, I'll take it to the 3rd to get rid of that. 1/3 power is like a cube root, so it's basically a cube root right now. Take both sides to the 3rd power to keep the balance. That makes this x plus 5 equals -1 to the 3rd is still -1, and then minus 5 for a final answer of -6. So those are your two final answers. You could take some time, plug them back into the original problem for the x's, and it should be able to verify that it makes this a true statement. All right, let's do another one that's of that type. Number 24 and 25 are the same concept. They're the u substitution idea. So when you look at number 24, let's see if I have a better marker. When you look at number 24, it has negative exponents, so it's not truly a quadratic in this form. Much better. So this is not to the second power, so the -2nd power. So it's not really a quadratic, but if I pretend like this is just u, this is that squared. It's in quadratic form. If you squared this term, you'd multiply your exponents and be at -2. So it is quadratic form. If this is what I let be u, I should make a note that I'm letting u equal that x to the -1 part. And then that rewrites it as 6. This would be u squared minus 31. That would be u plus 5. Now we've got to pretend substitute a quadratic, and then I solve that by factoring or the formula. I don't know just right offhand, but I would guess 2u times 3u to get 6u squared. I know my signs have to both be negative to multiply and get a positive on the end and still get a negative middle. I'm going to try 5 times 1. I can tell I'm not going to make it though. That does not work to give me a 31. So you try different ways, and I'm kind of seeing that I need a 6 times 1 here to get a large enough number to make this happen. And maybe the 5 over here. But this is how the process is if you do it by the factoring method. You just have to move things around. But now first is correct, and the last times last is +5, the inner, and the outer. So if I do the full FOIL method, I can check, and all the terms wind up to be correct. So once you've determined you've got it factored correctly, or you've used the formula to get your solutions, we get two solutions of 1/6 and +5. Those aren't our final answers though. We always have to look back at what we let u equal. In this case, it's the negative x to the -1. So we unsub or fix it back into its real value. These are interchangeable in our map key there. So what that -1 exponent does to these solutions is it'll flip them upside down. When I take each side to the -1 exponent to undo what's done here, that would be x to the +1, or x. But what happens when you take a fraction to a negative exponent is it's the reciprocal. It becomes 6/1, or just 6. Same thing here, this side will reciprocal and be 1/5. Notice the signs don't change, it just makes the reciprocal value of those. So those are our final two answers. And again, check them in the original and you can verify they work. Okay, one more example of that, number 25. So you'll get, probably one of these to get this concept tested. So you need definitely to know about the substitution method, how to do this u substitution in quadratic form. So the next variation of this, we're going to use u substitution for this middle term, and it's usually wherever the middle term is, because that's the smaller amount, and then if we were to square that, it would give you this first amount. So we let this be u, that makes that u squared. Always make a note what you're letting u stand for. In this case, I'm letting it stand for the x squared. So if that be u, that is u squared. And I can rewrite it as 25, that's what I'm calling u squared, minus 61u plus 36 equals 0. And so this is another kind of tough factorization. It's not something I just know right off the top of my head. I'll have to work around a little bit and see what works here. My first guess would be 5u times 5u to get 25u squared. I do know my signs are negative, negative to get a positive on the end, but a negative in the middle. Then I need to get 36. I want to try 9 times 4. I thought maybe somehow that might work. Let's check it. That's negative 45u, negative 20u, that's negative 65. I was close though, but that's not it. So, let's see, maybe 12 times 3 is 36, that's a thought. I think what else, 6 times 6 is 36. I might have to do something different to my 5s here and try that. Let me do that. Let's try 25 times 1. And, I think I need 36 times 1. Let's see if that works. I think 25 and 36 adds up to 61. This may do it. First is 25u squared, and my last times last is positive 36. My inner times inner is negative 36u, and my outer is negative 25u, and that does add up to be negative 61u, so that's our winner. So that's the factorization. FOIL that, it does give you that. So once you get it factored correctly, you set each factor equal to 0. Solving each part, this one will be 36 over 25, and this one will be 1. Remember, those aren't your final solutions though. You've got to unsub. Once you get u broken apart, your two u solutions, always look back at your key, what you let u stand in for, and change it back into its real value. So this is that process. All right, so we should have 4 answers to this, by the way, because it is a 4th degree equation. You're looking for 4 solutions, just like a 2nd degree, look for 2 and so on. So we're looking for 4 solutions, and that's going to happen because when you take the square root of something squared to solve that, you're supposed to say plus and minus of the other side. Now luckily this one is a perfect square, so it'll come out perfect. It doesn't always have to be this way, but the square root of 36 is 6 and the square root of 25 is 5, so it comes out of there already as a perfect square, nice square root. Plus and minus though. Same thing over here when I square root both sides to solve the x squared and the x cancel, bringing out the x. You have to say plus minus of this answer. So plus minus square root of 1 is 1. For a total, that's 4 answers. Positive 6/5, negative 6/5. Positive 1, negative 1. 4 total solutions.